Hey guys, how are you? Oh, that's software engineering energy in the room. Wow. So I'm Fredrik Jansson. I work for the TLF BU, the NSO team. I'm here to talk about NetConf Call Home. It's a pretty new feature that I'm really excited about, and I'll tell you in the middle of the presentation. I'm working on a project where this would actually be really helpful. So typically you have something like this in your network. You have an NSO installed. It's sitting somewhere in the middle of your network. You have a bunch of devices, routers and switches that you want to manage. And then you go into your NSO either through CLI or you import it through a CSV file, or somehow you register your devices by known IP addresses or known DNS names or something else. Key point is that NSO knows how to find your addresses on the network. So it's not always that easy, though, it turns out. In certain cases, you could think that you would have a device sitting behind someone's home router. That will be NATed out through static NAT or PAT or something like that. And you could manually configure that, I guess, to give access to that device. But that is not always something that you want to do, though. You have firewalls that actually, for a reason, prevent communication from the outside going in. Could be that you actually don't know the address of the device. Could be a DHCP device. So it's going to come up at some point. Maybe you have shipped this device to a customer. Maybe it's a CP style of device that you don't know if it's going to be turned off tomorrow or the next day or in 2 weeks. And maybe your customer actually turn it off once in a while. And then you have IP address changing. So let's say you have something on something like this, or maybe you have something sitting in a semi that is driving around, roaming between different networks. IP address is going to be changing all the time. And again, DHCP, you typically get the same IP address every time, but it's no guarantee, right? It could be that the next renewal, this device is going to get a new address. Point is, you don't always know the address. Ta-da! NetConf Call Home. It's a fairly new RFC. I should have checked exactly when it came out. It's RFC 8071. And not only does it cover NetConf Call Home, it also covers RESTConf Call Home. So therefore it has to cover both SSH for NetConf and TLS for RESTConf. And I'll show you on the next slide what I mean by only TCP changing direction. Actually do this. So typically when you have NSO connecting to your device, you're going to have NSO set up the TCP connection. This device is going to listen on port 8030 or some other port, but NSO is going to initiate the TCP connection. And once it comes up, NSO is going to start SSH, or if it's RESTConf, the TLS negotiation, and then you do NetConf. So NSO is the client in all these cases, and the device is the server. The only difference, and this threw me off in the beginning, is in NetConf Call Home, NSO is the TCP server, and the device is the TCP client, because it's actually the client calling back home to NSO. That said, though, once that TCP connection is up and running, NSO is still the SSH client and the NetConf RESTConf client. And this just threw me off a bit. Maybe I'm slow when I read the RFC, but that is basically the difference.
Is that a role reversal?
I'm sorry?
Is that a role reversal?
Yes. It's a role reversal.
Oh, okay. Yeah. In on the TCP layer, yeah. So what about us? So we support both in ConfD and NSO nowadays, NetConf Call Home. We don't support RESTConf Call Home yet. It was introduced in ConfD 671, 2018, something late 2018, I think. And it came in NSO 5.1. For other devices, our real CP style devices, it's on the XC backlog to be added. Fortunately, I don't have any dates there yet. For XR, I actually don't know. I'm not sure how important this is for XR devices, since they are maybe more PE style rather than CP-style devices. You can be the judge of that, but and I don't know about XR, how we're doing there. So how does NSO know what device it is? So what I'm gonna show you later is when you register your devices in NSO, since you don't know the IP addresses, what you have to do is you have to say which SSH public key your device is gonna call back with. And the way it works is, so the device is gonna establish its TCP connection to NSO. NSO is gonna do the SSH negotiation, and as part of that negotiation, it's gonna receive this device's public key. And then it's gonna go through its list and try to match that to the SSH keys we have in our list. And if it doesn't find anything, we're gonna kill that TCP connection, but we're gonna generate an event. And I'll show you later with code how you can use this. But you can actually subscribe to these events that the NetConf call home generates. So this is an unknown device. So it's basically NSO telling your code, should you choose to write it, that a device that I don't know, just call home. If it is a known device though, if the SSH key matches, you will actually get a similar event called call home device connected. And that will actually tell you, now it's router 1 calling home. And that means it's ready for configuration. So when I started thinking about this, it just felt super complicated to get this up and running. Turns out it's pretty easy. So you're gonna go into your NSO configuration to ncs.com. You're gonna enable netconf call home, say which IP address you're interested in, and if you're not gonna use the default port, you can override that. You're gonna add your devices, pretty much same what you would have, what you already know. There are kind of two differences. A local user, and I'll explain why you need this. This should be known to you. And instead of admin state unlocked, you're gonna put this guy in admin state call home. The reason we need a local user, I don't know if you ever thought about that. When you have authentication groups, you can have mappings. So if I log into NSO, with my username, I may want to use a different username when I talk to the device from when Sal logs in. So we can have different user mappings unless you have the default map. So if you want to use that when this guy calls home, the call home functionality is going to use this username to look at in the authentication group which user to connect to or which credentials to use towards the device. And brace yourself for the ConfD part. Super simple. It's one call. Call home. This is my NSO. This is the port. You can skip this if it's a standard port. So it's actually really simple to get this up and running. How am I on time? So these are the events. So the first one was the unknown device. And here you get basic information about the device. And probably the most important thing is the actual host key. So you can use that in different ways, maybe look it up somehow, or if you know you have no unknown devices, you're probably gonna ignore this, but it's, and if it is a known device, the only difference is it gives you the same information, but it also tells you which device in the device list it is. So now you can do different things in your code with these events. Demo time. See how this works. Is this font size okay for everybody? Is it okay for you guys in the back? Alex, one. So I prepared a little demo. So in my Fusion here, I'm running a ConfD in a Docker container. And the only reason I do that is I want to be able to play with the networking a bit. So this VM has 2 NICs that I can turn on and off. So I can actually force it to switch IP address to just prove the point. And since it's running in a Docker container, it's actually going to be NATed once before it hits the NSO. And the NSO is just running on my laptop. So let me show you. Show devices list. So here I have my router 1 that I'm going to fire up in here. It's configured as a call home device. So it's exactly what I showed you before. Local user admin, the public key, and importantly, it's going to be a call home device. So if I try to do something now, if I do router 1 config hostname test1 and I try to commit this, now it's not connected. I'm gonna get an error saying this guy, I don't know it hasn't called back yet. So let's switch over to the VM, and I actually have a small script that I run. Pretty amazing, right? See this? It's like 1984 again. So this is just a blank. It doesn't have any config yet, so it doesn't have any host name, and this just prints out the current IP address. So with that, if I go back now, it should actually have called home to NSO. So if I commit this, fingers crossed. Oh, I've got to sync it. It doesn't do that automatically. So do a devices device router 1 sync from commit, and then test1 hostname. So now if I do this, if I go up here, I'm gonna disconnect 1, so it's 2 or 3. Gonna connect it to the other one. So now I'm actually forcing this guy to have a new IP address, and just to disconnect. No, oh, here we go. So new IP address, I can set a different something here. Commit test2. It's pretty cool, but this gets old pretty quick. That you gotta wait for the device. If I guess if you know it's gonna call home and you're sitting there at your CLI and just waiting for it, and you test a couple of times, that will work well. It doesn't feel very automated to me though. So we have this thing called commit queues, and that is actually working pretty well with this. So let me show you. So I'm gonna disconnect this guy. So now it has no IP address. We will see an error soon saying it can't connect. So now if I change the host name again, I do a commit queue, just async. So now it's actually waiting. If I do show devices commit queue, I can see that I have an item waiting for me to be sent to the device. So let me enable this one of the networks. It's gonna come up, and then it should switch over to test 3, fingers crossed. Oh, bug. Pretend, rewind in your head, this never happened. Let's give it another shot. Commit queue, async. What do I do now? Router 1, commit queue. No. I love this. Commit queue. Here we go. Clear the entire thing. Let me try again. Oh, test 4. It worked. Where are the applause? Thank you. I actually started sweating a bit. Once we figure that out, this is. But honestly, it's. I think with commit queues, it's actually really cool. You could actually pre-configure these guys, and as they come in, it's like bit like PMP. As they come in, they're gonna pick up that configuration, and then they can actually go away again if needed. So next thing I thought I'd show you is if you want to automate this. listen to those events that I told you about. So I'm gonna stop this. Actually, I can keep it running. So the first one I want to show you is, I'll switch down here. So this is just a small script that I have that is waiting for, you know how much time I spent on that, getting it to ring? So it's just to show you. It's a small Python script. I'm subscribed to those events. So this is a call home device connected. It's a known device. So what can I do with this? I can, for example, if this is a known device, I have another script that is actually waiting, and once it comes back in, it sees that it's a known device, just prints out the name, and then it does a sync from, if that is what you want. So you could potentially wait for the device to come in, it could do a sync from, and maybe make a config change and push that back to the device. So let me switch now to, I'm gonna stop this. I'm gonna switch back here, and I'll just tell you in a second what I did. So I restarted the container that I have, but now this time it's gonna connect using an SSH key that I don't know about. So this is a different router coming in. So if I do a wait for this notification and I restart this, you will see that this time I get a call home unknown device. So no device name, otherwise I'll get the same information. So using the other script that I wrote, I can do this. So this will, now it's an unknown device. It will actually see that it's something that it doesn't know, and it asks me now, very unautomatable, do I want to add this as a device? Yes. So it now added this as router 2, and now when it comes back, see, my demo is going, oh, here we go. It took a while. So it added it a couple of times. It doesn't matter since it's NSO, right? You can add same device as many times as you like. It doesn't make any difference. But then it's gonna come back, and now it's actually a known device. So it's gonna fall into the other track and do a sync from. So if I switch back to my NSO here, I now have a router 2 in here that I just added. And this is not a whole lot of code. So it's basically I'm setting up at the very bottom here that I wanna listen to NetConf call home information. This is the event, and every time I get one of those events, I'm gonna end up in this handle call home. And here I have a basic switch. If it's an unknown device, I'm gonna take this path. If it's a known device, I'm just gonna sync from it. And this should be pretty familiar to you guys if you programmed in Python before. But it's basically, it's super simple. You get it as a Python map, and you can look up the SSH keys. And in my case, I just added it as a device. Maybe you wanna log it or go to some other system and look it up. It's up to you. And that's actually all I had. Any questions?
Yeah, Mike's back on. Let's see, go on in the front row, or almost front row.
I just had a question on the demo that you gave where there was the connection failure that we're supposed to not remember, but on the connection failure,
Dude.
So did the commit queue fail because like the IP address? Because you changed the IP address, right? So did it fail when it tried to come back home, and then the commit queue didn't know how to interact with it, or like if the IP address would have been the same with the commit queue?
No,
I'm curious why it failed.
It's actually a bug that I haven't received a fix for yet. So
okay,
it's
a bug that
yeah.
you've like put in to get fixed for the.
Yeah,
NSO?
it's I shouldn't say this, but it's a bug in NSO, and they haven't fixed it yet. So
Second question: what version are you running?
5.1.1.
Okay, thank you.
Sure.
one small question. Is there any way for the device to auto-discover the address of the NSO server, like we have for PMP and ZTP, some DHCP discovery, DNS discovery, something like that? Or?
No, nothing built in that I know of. No, you're thinking like a redirect to a. Yeah, no, I not built into this. You would have to, if you put it as a DHCP code or something like that, you could probably read out that, but it's nothing built in that I know of. That's a neat feature, though.
Okay.
Sorry, so after my last question, I was thinking, and from my understanding of how commit queues work, if the device is like powered off or if it can't get to it, the commit queue will keep attempting to resend to the device. If it gets something like a CAX timeout, it just fails the commit queue, but if it's something like powered off, it will continuously attempt to send to the device. So in a situation like this with the call home, where the IP address may be the same or different, would you just put it in a commit queue, and is there like a variable that you can change so it won't attempt to call to the device and it can just sit and wait for it to call home? Is that a difference?
Well, so in this case, NSO can't really call the device, right? It wouldn't know where to call, so it would actually just have to wait and keep its fingers crossed that that device is going to call home at some point.
Is that because of the admin state? Do you still set an IP address for it, or if you set that admin state, do you not set an IP address, and then that's the difference of how it interacts?
Well, so typically you don't set the IP address at all in this case. I mean, you do get the you do get the IP address sent to you, but it's if you know it's going to be stable, you could actually, I guess, switch this device from a call home device to a normal device and have the code put in the IP address and change it from NetConf call home to like unlocked state. But that would be then it would be like any other device, and that device better not change its IP address, right?
Okay. So
Am I answering your question, or?
I think so. So it sounds like it's the admin state that changes how it interacts. Where like if it's southbound lock, it would just fail to push the device, and then it would just break out of the commit queue. Where the southbound lock or the call home will just have it sit there and wait for it to interact.
Exactly. Yeah.
Okay.
Exactly.
Perfect.
Yeah.
Thank you.
Exactly. But I don't think typically with those devices that you will actually change them. I would assume that they're gonna be NetConf call home devices for the duration of their lifetime.
Yeah, that makes sense.
But I can see, and I actually, so I forgot to tell you in my presentation. So I'm working on where I have actually been thinking along those lines that you say. We actually have a project now where we deploy applications in Kubernetes, and each of those actually have a ConfD. And at the moment, I have no real good way of, so I'm deploying these applications, and as they come up in the Kubernetes cluster, I actually have to poll and see if hey, are you up? Are you up? Are you up? And then a minute later, it's going to connect and all that. With this, I could actually have the devices call back to NSO. Once they come up and are booted in the cluster, they could actually call home to NSO. And in that case, I know it's going to be going to have the same IP address for the duration of the lifetime. So in that case, I might actually switch that device through code from a call home device to a normal NSO device.
All right. Thank you.
Sure.
Okay, right over here.
Hi, thanks for your presentation. When we are making like a HA establishing like with the master and slaves, and I don't think that we have the configuration of the IP address. In this case, 192.168.44.203 is not the other configurations, and that is an operational data in NSO. So that has to be also propagated to the slave. So when we are seeing the master slave switching over, there will be no problems.
With HA, if you have the device connected to this NSO and this NSO dies, that device is going to have to do a new call home to this NSO, right? So I don't think you need to actually sync that operational data, because the device is going to have to reestablish. I mean, the TCP connection has to be reestablished from scratch.
So okay, so then for the device needs to reinitiate from starting over. Basically, in a normal NetConf connections, yes, the TCP needs to be reinitiated. But yes, I understand now.
Yeah. I mean, the device has to realize that the TCP connection died, and reestablish to a new NSO, either through using DNS or BDP. Somehow it has to find its way to the new master. Yeah.
Thank you.
I think we got time for about one more question. Anybody else? Let me go back up here. All right, I think we're there. So I guess two things. First of all, thank you, Fredrik. A round of applause for Fredrik.
Thank you.
Cisco, the bridge to possible.